Jonga. This is how. Yeah, you wanna learn. This is a complex stress system. So we're going to find first. Look at the first principle. Okay. So we're going to consider or focus on this triangle, which is that one. Okay. Okay, we see that one is compressive, and then the other one is anti-clockwise, which is look at this one. So I'm gonna go ahead to define the magnitude of each value, of each stress. So we see the sigma y is 5 megapascal and sigma x is 7 megapascal and shear xy is 3 megapascal. So that's our shear, that's our sigma y, sigma x, and then that's sigma y. Okay, yes, that is the lot for 8. The reason that one is sigma y is acting on is as more like compressing on the y face. When it's compressing on the y face, we name it sigma y. When it's compressing on the x face, we call it sigma x. So look at that one. There's you need to look at the convention between these two, which is the shear max, the shear stresses. The one that tends to go clockwise is positive, and the one that's go to anti-clockwise, it's counterclockwise, then it's negative. So you're gonna see how this thing is going to help us, especially when we are looking at the shear, and also when we're looking at the direct stresses. We need to pay attention on the one that is negative, on the one that is positive, so that we're going to know what direction are we going to get, which is compressive or tensile at the end. Okay, those are our direct stresses to the plane, and the parallel one, which is a shear. So now go ahead to plot the direct one, which is our shear. This is our sigma, direct sigma. And then now I'm gonna look first. Okay, I'm gonna look on the 3, the one that is going to the right, to the left, which is 3. The one that is going to the left, that is okay. So that's our shear, that's our direct stress. So that 3 megapascal, we're going to put it there because it's going like that also. Okay, so we have 3 megapascal, which is on the cos face. That is the cos face because it's the side on which the angle is located, and then the other one is sine, obvious, sine of 48. And then let me extend here so that we're gonna have a nice clean components there. Okay, so we're closing that one, and then that one is remember that is inclined at 48, so we need to locate where is 48 in this. So 48 is there, that's an alternate angle. Okay, so now we're gonna focus on the one that is going down, which is I'm gonna extend that one as well, so that each one is gonna have is going to have its own line. Okay, I want it to be clean as possible, and I want to make sure all the angles are there at the center. Okay, so it's easy when you're doing like this, all the angles are there at the center. It's easy to find the angles. So it's 7 cos of 48 because it's also located on the side of the angle. So that one is there. Remember that it has to be 80 degrees, it has to be 90 degrees. Therefore it to be 90, we need to find what is that short small, that angle short there in between to complete. Okay, so we know that after it's going to be 48 again to make it 90 degrees. Okay, so now we need to find what is the side. So now the 48 is the other side. So we see most this one is going to be cos sine, because we have sine there on top, so it's cos sine. And then that one also is going to be sine. So now, and cos, because we have our r as cos, and then that side is going to be cos squared. Okay, 48. And then now focusing on the one that is going up. Okay, so we're going to join it from this side. Okay, so extend this line. Okay, now going to have our shear going that side, which is now we're going to join it from this direct stress on our plane. So what about this? Okay, fine. Yeah. So okay, now remember that I'm just making sure that everything it comes out clean. Okay. 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 Okay, I'm just making sure everything that comes out clean, and you can see it from that side. So we're focusing on that 3 now. Remember that 3 is our shear, and then I want to define the components of that shears. Okay, so now we know that the component that is associated with the angle, we know it's given by cos, so we're gonna have cos of 48, sine of 48. Remember the our radius there is sine, which is 3 sine of 48. So now that one is going to be 3 sine squared of 48 because our radius is sine. 3 sine 48. So this is it. So now from here you can find your, so I meant to say I made a mistake there above. I looked for, so now we need to pay attention on the direction of our shear stress. You see our shear stress is going that direction. So now look there, we focus on the shear stress. We see that shear stress that is going up, which is trying to cause negative things there, which is anti-clockwise, counterclockwise. So we're going to focus on that one so that we see the direction of each so we see the direction of each shear stress on the system. So we can see that this one is also pointing opposite of the negative one. So it's going to be plus whatever that is going to point upside down of the positive, I mean of the negative. Remember the negative one I have already shown you there. So you see this one is going opposite of this. You see this one is going in that negative direction. Remember that is guided by that 3 sine 48 because there from on our diagram that's 3 sine 8 is negative. So anything that is going to the side, to the direction of that one, is going to be negative. And then anything that is associated with the positive, I mean with the opposite direction, it's positive. So you can follow, as you can see. So this is what is going to give us the correct answer when we are looking for directions, which is compressive or tensile. Okay, so we adapted this culture. Okay, so you can see now okay, so we're gonna add now, which is we're gonna add that one, which is plus sine, I mean 7 sine 48, because is in the opposite direction. Remember, opposite direction of what? Of 3 sine squared. Okay, so now we're going to look at for the other one again. The other one is also add 5 sine, or we can say cos 48 sine 48 is still the same thing, but okay, yeah, in that respect it's okay. So now actually this thing is right. It's just that I did it like looking at shear stress, but now I need to look at the direct stress. So the direct stress that is negative there above, which is 5 megapascal, so that one is associated with negative. So anything that has to do with that one in the direction of direct stress is going to be negative. Okay, then the opposite is true. So we see that that one is in the favor of that one, which is, so anything that is pointing up like that, so that one is positive because it's pointing down opposite of that 5 sine squared 48. So anything that is pointing opposite of that is going to be positive. So negative and negative, negative and positive. So that one was actually correct. Just that I was only focusing on my shear when I was doing that. I made a mistake there, but now sometimes it's not going to be always the case, but just make sure that you follow what I'm doing and you follow the right thing. You don't make mistake. Okay, so from here I believe this thing that the rest is easy because it's just a matter of taking what is in front of you based on the direction, and then you represent it on the paper, and then you get your sign as negative or as positive, which is it indicates compressive or tensile. Okay, so this shouldn't be hard, it's easy.